All right, so this is Chapter 7, Part A, Exponential Review for your exam tomorrow. I've written these 4 equations that you will be given on the test. So go ahead and write them on your paper now so that you have them. So this is exactly how I'll give it to you, where I'll write them up on the board, but I won't tell you what each variable represents. So you'll have to know that the number in front of all the parentheses and this letter P here in front of E, that's all your starting amount, what you start with. This equal over here is what you're going to end up equaling, what the final amount will be. The R is always your percent as a decimal. T is always time in years, so if it's in months, you have to convert it to years. For this one, this is N when they say compounded something other than continuously, so compounded weekly, monthly, etc. The N represents the number of times it's compounded, so if it says quarterly, that's N equals 4. If it's monthly, N equals 12. Weekly, N equals 52, etc. This one, this last equation you use is whenever it says compounded continuously. So compounded continuously, we no longer have the N variable, we have this E, which represents 2.718. It's that number that goes on forever and never repeats. Okay, so if you need to pause to finish writing those down, you can. So what we're going to do for this is that I'm going to give you 2 minutes per problem. So I will time it. So keep the video rolling, and this will serve as your timer. So I'll show you the question, and then you'll work out that question on your paper with the corresponding number that it goes with. Okay? All right, so here is your first question, number 1 on your paper. Time starts now. You have 1 minute left. Thirty seconds left. Okay, try and finish up in the next 10 seconds. All right, time's up. Okay, so let's go over this problem and check and see if you did it right. So I'm going to fill out my asymptote first. So remember how you tell from an exponential is your asymptote is always this k value. And it's the equation of the horizontal line, which is y equals -3. You keep the sign. Okay? So then I know I go on here where y is -3, and then you're going to draw your dashed asymptote line. So you will lose a point if you do not draw in this asymptote line. Okay? You draw it in dashed. So then we can type this into our calculator. Um, so I'm going to go to this and then clear that out. So 2 to the, what was it, x plus 1 minus 3. X plus 1 minus 3. And I'm just going to look at the table. I'll look at the graph as well. So I just want you to graph 2 points. So you can pick any 2 points on here. I'll pick 1, 1, and 2, 5. So 1, 1, and 2, 5. And then just so you can see what the shape is, so you want to look at the graph. And you'll notice that it should confirm that at y equals -3 is where it's leveling off. So then you draw in your shape, which should look like that. And this is an exponential growth because the base number is bigger than 1. Okay? So then our domain is going to be all real numbers. Our domain for exponentials are always all real numbers. And then our range is going to match where it's y, and then it's this number -3. And then we have to decide if it's greater than or less than. And since we're using everything above it, it's greater than. It won't be equal to ever because it gets closer and closer but never touches. That's what an asymptote is. So this is a 6-point problem. You get a point for graphing 2 of the points correctly, 1 point for your shape, and then 1 point for the asymptote on here, then 1 point per blank. So that's points. Okay, so this is growth. So if I ever ask you if this is exponential growth or decay, it's growth because the base number is bigger than 1. Okay? All right, here is number 2. So work on that one. You have 1 minute left. Thirty seconds left. So 10 seconds to finish up the problem. Time's up. Okay, so looking at this one, again, your asymptote, this is one of those natural base functions. So the way we find the asymptote is still that k value. So that'll be y equals 1, and you keep the sign. So then on my graph, I go to y equals 1 and put that dash asymptote on there. Okay, now I'm going to type that in, e to the x plus 1. So equals, clear it out. So remember, E is if you hit second and the ln button, and e to the x, and then plus 1 is not in the exponent. So let's scoot over, plus 1, graph. So there's our shape, and that shows that it does level off at positive 1. So let's get a couple values to graph. So we have 0, 2, and 1, 3.7. So I'm going to graph the points 0, 2, and 1, 3.7. And it's okay if one of them's a decimal. You can estimate that like I'm going to. So 0, 2, and then 1, 1, 2, 3.7 is about right there. And then as we saw, the shape was this. So then domain is all real numbers. And our range, again, remember, matches the asymptote y and the 1. And we're using all the y values above, so it's y is greater than 1. Okay, very good. Okay, here's number 3. So go ahead and work on that problem. You have 2 minutes. You have 30 seconds left. Ten more seconds. All right. So, in 1993, Fisherman's Lake held 16,000 catfish. The catfish population increases 11% per year for the following 4 years. Find the catfish population of Fisherman's Lake after 3 years. So first you have to decide which of those 4 formulas you're going to use, and it should be the exponential growth one. It doesn't say compounded anything, so it's the y equals a times 1 plus, because it's increasing r, all raised to the second, or to the t power. So then our starting amount was 16,000. 1 plus, if I take this decimal and move it 2 to the left, then that makes it 0.11. And I want to know after 3 years, so to the third power. Okay, so let's type that in. So 16,000, 1 plus 0.11 to the third power. Now, this problem doesn't make sense to leave decimals, because we're talking about actual catfish. Just like if we're talking about people, we can't talk about half a catfish or half a person. So then we're just gonna cut it off. So 21,882. So you always have to have a label on these real world problems ones. So 21A2, yep. Now these will be worth 2 points on the test if it's not a multiple choice problem. If this is a multiple choice problem, then it'll just be worth 1 point for whatever the right answer is that you choose. But otherwise, it would be a 2-point problem because you need to show me what you're typing in your calculator. Okay? All right, here's the next problem. So this was from that natural base E. So remember, I'll give you a hint on this. Simplify means you're not going to type it in your calculator. It just means that you are going to simplify and will have E in your answer. Okay. One minute left. Thirty seconds left. Ten seconds. All right, time's up. Okay. So when it says simplify, we leave E alone like it's a variable. And so we'll just do the exponent rule. So right now this is 2 to the first power. And when you have an exponent outside, you're supposed to multiply the exponents together. So 1 times -4, so that'll be 2 to the -4 power. And then -2 times -4 is +8. Now you cannot leave negative exponents. So remember that means you need to move it. So it would go to the bottom of the fraction. E to the +8 stays on top. So then you would have e to the 8th over 2 now to the +4th power, because once you move the exponent and its base down, then it becomes positive. Now you just need to evaluate that 2 to the 4th to simplify, which would be 16. So you don't evaluate the e to the 8th because that actually would give you a decimal number. We're just simplifying it down to this point. That's as far as you can go. Okay. All right. All right, here's your next one. This was the last set of notes we did, and this was the one where you have to use your graphing calculator to do this. So 2 minutes starting now. 1 minute left. Thirty seconds. Ten seconds. All right, time's up. Okay, so this is the one where you need to put it in your calculator. So then we go stat. You have to edit, because you have to edit your lists. Remember, list 1 are the x values. So my x values are 1 and 3. So 1, enter, 3, enter. Then you have to enter the corresponding y values, which are 2 and 50. 2 and 50, enter. Then you hit stat again. This time we want to calculate, and we're calculating exp for exponential function. Then your list 1 is your x's, list 2 are your y's. Hit enter a few more times. Okay, now it tells you what the equation should look like, so you're going to plug in the a value and the b value. So 0.4 times b, which is 5, raised to the x power. Or if you wanted to write it this way, y equals 0.4 times 5 to the x, that also works. Either one works. Okay, good. All right, here's your next question, 2 minutes. You have 1 minute left. Thirty seconds left. Ten seconds. Okay, time's up. Okay, so since this said compounded continuously, then that is your hint that it is the PERT formula. P times E to the RT power. So we want to know the amount after you deposit $500. E is always just E. Our rate, if I take this and move it 2 to the left, it's 0.05. That's in the exponent. times the number of years, which is 2 years. That's also in the exponent. Okay, so now let's plug that in. So 500 times e to the 0.05 times 2. And this time, cents, 2 decimal places makes sense here just because that is the cents for your dollar amount. So $552.58. I would take it also if you said 59 if you rounded it because of the 5. But typically banks won't give you that extra little bit there. So I'm just going to write $552.58. Yep. So there's your answer. Okay. So again, that'd be a 2-pointer, especially if it's not multiple choice, you will need to show your work like this one. And so it's a 2-point problem. Okay. All right, here's your next problem. 2 minutes starts now. One minute left. Thirty seconds left. Ten seconds. Okay. So describe the translation. Remember, this is just our general equation where the A, the H, and the K all do something to it. Now this base number here, the base number is 3. So that's kind of like it's in parentheses and it's untouchable. I know on the practice test there were some people that said if you saw this number 3, you said it was steeper. It's only steeper if there was an additional A value in front, like 2 or something like that. Or a fraction would make it increase slower or be a little wider. So this 3 is the base. It does not do anything, so ignore it. Okay? So up here in the exponent, that's our h value, tells you if you go right or left, and it's opposite of what it looks like. And then your k value at the end is up or down, keep the sign. So this isn't wider or steeper because, again, that 3 is the base number. It's not the a value in front. Okay? So we would say shifts left 1 because it's opposite of what it looks like here, and down 6 because you keep the sign for the K. Okay? All right, here's number 8. So your 2 minutes starts now. You have 1 minute left. Thirty seconds left. Okay, time's up. All right. Since this one said compounded semi-annually, that's going to be this formula. Okay. And semi-annually means twice a year. So that means n equals 2. Okay, so she deposited $750. So that's your P. 1 plus, move this over twice, 1, 2. So that's going to be 0.0425 divided by your n, which is 2 in this case, and then raised to the n times t. So then that'd be 2 times 4 years. Okay, so let's type that in. So 750 parentheses 1 plus 0.045 divided by 2 raised to the 2 times 4. And again, since this is money, 2 decimal places make sense. So $887.39. I would also take if you rounded it to 40 cents. So $887.39. So that's your final answer. So again, this would be a 2-point problem if it wasn't multiple choice. Show me what you're plugging into the formula and what you'll put, which is also what you'll plug in your calculator, and then your answer with a label. So again, 2 decimal places made sense here because this was money. On that very first problem that we did earlier, that was this one, when it talked about catfish, it did not make sense to have a decimal, so we just cut it off to the nearest whole number. Okay, here's your next problem. 2 minutes. One minute left. Thirty seconds. Ten seconds. Time's up. Okay, so another describe the translation. You will have this type of problem on the test. So this one is an exponential decay because this is a fraction. So that, though, you don't look at this number as your a value. So the base number doesn't count and doesn't do anything to the problem. But this does. This negative in front means that the graph is flipped. So flipped on x-axis. There's nothing here to go shift right or left, but there is a k value, so it shifts up to. So again, the base number, whatever this number is that's attached to the x exponent, does not do anything to the graph. It just tells you if it's exponential growth or decay. It's just if there's anything in front of that base number multiplied, which this one had a negative, so it flipped it on the x-axis, and then it did have a k value, which shifts it up to. Okay. Here's your next problem. I'm only going to give you 1 minute on this one because it shouldn't take you a full 2 minutes for the asymptote. Thirty seconds. Ten seconds. Okay, time's up. Okay, so this one we just want the asymptote, so that is always y equals a number for exponential functions, and it's always y equals this k value. So y equals -1 is your asymptote. Okay. All right. Solve the equations. I'll give you 2 minutes on this one, starting now. One minute left. Thirty seconds left. 10 seconds. Okay. So these were the problems where you have exponentials on both sides. And so the first thing you have to do is make sure you have the same base on both sides. And I do. We have 5s. So we're going to ignore the bases, and now you have to set this exponent equal to this exponent, because if the bases are the same, then the exponents must be the same in order for the two sides to come out to be equal. So then to solve, we do x plus 1 equals 3x minus 7. And now this is an easy equation to solve. Okay, so let's see, minus x. So 1 equals 2x minus 7. Add 7. So 8 equals 2x. So then we divide by 2, so x is 4. Now, not that I'm asking you to show the check. I am going to just check over here. You should at least mentally check it. So that'll be to the 4 plus 1 power. This will be 5 to the 3 times 4 minus 7. So that's 5 to the 5th. That'll be 12 minus 7 is 5 to the 5th. So it works. Okay, so x equals 4 is the correct answer. Okay. Now, if the bases aren't the same, then we'll have to change them before you can set the exponents equal to each other. So there'll be a practice problem like that coming up soon. Okay? All right, here's your next problem. Time starts now. One minute left. Thirty seconds left. Ten seconds. Okay, time's up. So first, with these story problems, you have to decide which equation you're going to use. Compounded monthly is this formula. And monthly is n equals 12 because there's 12 months. So we want to know the amount after $2,000 is deposited. Move 2 decimal places to the left, so we get 0.0425 divided by n, which is 12, and then 12 times 3 years. Okay? So 2001 plus 0.0425 divided by 12 to the 12 times 3. Again, money may, or 2 decimal places make sense for money, so 2,271.45. 2,271.45. And if you rounded it up to 0.46, that's okay. I'd take that. Although, again, not very many banks will give you rounded up for you. Okay, so 3 more problems. Here's the next one. Solve the equation. 2 minutes starts now. 1 minute left. Thirty seconds left. Ten seconds. Okay. Okay, so looking at this, we have a 3 to the x plus 1 power, so 1 base of 3, and then we have 1 over 27. Well, if you look at this number 27, I can rewrite it as a base of 3 raised to a power. So I'm going to take this, and then you ask yourself first, since there is a fraction here, then you know it has to be a negative exponent. And then you have to ask yourself 3 to what power gives me 27? And it's 3 to the third power. So that's how you figure out how to change this base. If it's a fraction, then it has to be a negative exponent. And then you look at that bottom number and say, okay, this 3 to what power gives me 27? And it's 3 to the third. And you may have to type some stuff in your calculator if you just don't know that. Okay, then the rest of it stays the same. So this is still 3 to the x plus 1. And then I just bring down that x minus 3 in parentheses. Now, since I have the same base, we ignore the bases, and I set this exponent equal to this exponent. So I get x plus 1 equals negative 3 times parentheses x minus 3. Okay, now we do the algebra. So we're going to distribute first. And then I'm going to add 3x. So we get 4x plus 1 equals 9. 1 for x equals 8. Divide by 4, x equals 2. Okay, so I'm going to go back to the original and test it out. So 3 to the 2 plus 1, and we're going to see if that equals 1 over 27 to the 2 minus 3. I'm just plugging in this 2 in the x spots. So this would be 3 to the third power, and this will be 127 to the negative 1 power. Well, 3 to the third is 27. And then to the negative 1 power means you just turn it around, so it's 27 equals 27. It checks. And if you need to, you could have typed this into your calculator, hit equal, type this in your calculator, hit equal, and make sure you get the same number. Okay? All right, next problem. 2 minutes starts now. One minute left. 30 seconds left. Ten seconds. Okay. All right, so this is one of the calculator problems. So we have 1, 2, and 2, 16. So we go stat, edit. We have 1, 2, 1, 2. And then we had 2 and 16. Then stat, calculate, and this time we want the power regression. And it should be list 1 as x, list 2 as y. Hit enter a few more times. Okay, so again, it tells you what the equation should look like. And so this is different than the exponential because the x is now the base number instead of the exponent. So we have y equals 2 times x to the third power. So the power function, the x is the base number. And then when we did the exponential, what was that? The x was in the exponent spot. Now, it's nice because your calculator just tells you that. It shows you what the equation should look like each time. So here, it showed us what the power function looked like. So you knew where x was and what to plug in for A and what to plug in for B. All right. Last problem. And your 2 minutes starts now. Now this is one of those where you have to change both bases because 4 and 8 can be changed to a number raised to a power. One minute left. Thirty seconds left. Okay, time's up. All right, on this last one, there's no way you can keep a base of 4 because 4 to the first power is 4 and 4 to the second power is 16. So there's no way you can do 4 to some power to make it equal 8. So this is one where we have to change the 4 and we have to change the 8 so that we have like bases. Well, 4 is 2 squared and 8 is 2 to the third power. And then the rest of it stays the same. So we have x plus 1 equals, and then x minus 3. Okay, so this was one where you had to change both. I couldn't keep 4 because 4 to some power, I can't write it to make 8. Because 4 squared is 16, not 8. Okay, so now that we have the same bases, I have a 2 and a 2 as my bases, then set this exponent equal to this exponent. So 2 times parentheses x plus 1 equals 3 times parentheses x minus 3. You have to distribute. So 2x plus 2 equals 3x minus 9. Then I'll subtract 2x. 2 equals x minus 9. Add 9. X equals 11. So then we can check. 4 to the 11 plus 1 equals 8 to the 11 minus 3. So that's 4 to the 12th equals, right, yeah, 11 plus 1 is 12, and then 11 minus 3, so that'd be 8 to the 8th power. So we could check, make sure that's right. So 4 to the 12th, keep that in my calculator, and then 8 to the, what was it, 8th. Same number, so we're good to go. So x equals 11 is the correct answer. Okay, so that gave you 15 practice problems of the types of problems that you're going to see on your test tomorrow. You will make sure that your name is on this worksheet, and you will turn it in to get your final chance for a check mark this chapter for your participation in this. Once you turn it in, if there's any time left in the block, then you should be working on doing your Cornell note repetitions. So remember the ones that you should have. You should have a summary that answers the essential question for each day, and you should be current on those because I checked almost every single day on those. And then 3 study questions. And again, that's one that you had to do after each set of notes. So hopefully you're caught up on that. So then the 2 that you need to make sure that you do is highlight main ideas. If you don't have a highlighter, you can underline main ideas. And circle key terms. That's considered one repetition together if you do that together. And remember, when you circle the key terms, you circle it, but then you read what the word is and whatever its definition is. And key terms count if I gave you steps to do something, then you circle the steps and then you read the steps to yourself. Okay, that's going to help you retain more of that information. And then the other one is go back and answer your study questions. So if it's a level 1, like what is an asymptote? Well, then you don't have to rewrite that. So if yours was what is an asymptote, and I had given you that definition, then you just would draw an arrow over to the notes where it gives you that. But your level 2 questions, which were the examples that you came up with on your own, you do need to rework those out on the notes side. So if you don't have any room and you did yours on hard copy paper, you can get some Post-its that I have up by my desk and write your answers on those Post-its. You are not supposed to be writing your answers on the side that you wrote your questions on. So I do not want to see the answers to your questions underneath your question in the left-hand column, because what you're supposed to do, remember, is to cover up the notes side and only see the questions, and then you answer the question and then you check your answer to make sure it's right. So the question and the answer both should not be in your left-hand column. So you will lose points for that if you do that. Those of you on OneNote, you have unlimited amount of space. So you could always scroll over and use this, even if it's not within the notes, the lines on your notes, you could write off to the side and move it over a little further if you need to. Okay, and then just draw an arrow as to where that is so I can find it if it is off of the page a little bit. Okay, so use the rest of the time to do your Cornell note repetitions, which will help you study for your test. I also recommend, not that there's any way I can check this, but I do recommend go back and answer the examples in our notes. So we already worked out the examples in the notes. then what you should do is to go back, look at the answer in the notes, or I'm sorry, read the example that we did in the notes, cover up the answer so that you can't see it, and rework it on another piece of paper, and then check your answer and see if you got it correct. So that's another way in math how you can study is you go back over the examples that we did together. You should have all the correct answers for those examples. So cover up the answers to the examples, rework the problem on a piece of paper, and then you can check if you did it correctly. Okay, so use the rest of the time to study. I'll be back tomorrow, and tomorrow will be your test. I'll be able to take a few questions before the test, but not too many because I want to give you as much time as possible to finish the test. Okay?